and Tony?
Nah, not really.
Oh, really? Oh, you and Tony are getting divorced?
Okay, can we not?
Oh.
Can we not? And no, we're okay, so we are multiplying by 2 each time. We are multiplying by 2 each time. When you are multiplying the same number every time, your formula will start out with that number to an exponent. That's what's going to happen for sure. When you're multiplying by the same number each time, your a sub n is going to start out with what you're multiplying by to an exponent. Now we have to figure out if that gives us the exact answer or if we have to do something else to change it. So then I'm going to start thinking about my input number. I'm going to think about input 1, input 2, 3, 4, 5. I'm going to think about the input numbers. If I input into n, I'm going to just start at 2. I don't always like starting at 1. I'm going to start with 2. If I input n and I make it a 2, so I do 2 to the 2. I have to get out what? That's what I have to get out. So 2 to the 2 is 4. It's not 1, is it?
Well, subtract the 3.
That might work. Let's try a second one. So we'll do 2 to the third. And that has to equal 2. So if I use your subtract 3, does that work for both?
Yeah.
8 minus 3 is not 2. So that's not the answer. So we would have to erase. I'm going to put one more of them down. 2 to the 4 has to equal 4. I just have a few of them down, and we got to figure out what's happening. And I will tell you, sometimes there's more than one right answer. So we might come up with, I mean, they're related to each other, not completely different, but we might come up with an idea, but you had an idea that was totally different. Feel free to ask. I'm going to teach you the way that, like, the book might have answers for it. So for each of these, I'm going to look at this one right here. For each of these, we've got 2 to the third, and all of a sudden it equals 2. I know that 2 to the first is equal to 2. How could I make this 2 to the first instead of 2 to the third? Okay, so for the next one, would I subtract 2 also?
Yeah.
Will that work?
Yeah.
Will that work for this one if I do 2 minus 2? 2 to the 0, is that 1? Yes, we learned that rule a while ago. Anything 0 power is 1.
So if you do the first power, if you did the first power, you subtract the 2, makes it a negative 1.
Right, so let's check that first one. If I do 2 to the 1 minus 2, that gives me 2 to the negative 1, and we should have learned that when you have a negative 1 exponent, it says to reciprocate it, make it a fraction. 1/2. So our final formula is going to be a sub n equals 2 to the n minus 2. And you don't necessarily need those parentheses in the n minus 2. I'm just trying to make sure you all know that the n and the minus 2 are in the exponent. Okay? So now you start looking at that next one. I know you've already kind of looked at the formula. We did that last time. Are we multiplying by the same thing each time?
No.
Yes.
We're done by
We're done by a half.
So, I don't really have a divide by rule, but I do have a multiplication rule. So if you're multiplying by the same number each time, it's going to be that number to the exponent. So instead of dividing by 2, we can multiply by half. So I'm going to start out by saying, all right, it's got to be 1/2 to an exponent, but I might have to change things. So now you have to figure out how you can make 1/2 into 8, and how you can make 1/2 into 4. But you also have to come up with where I put my input number. So if I do 1/2 to the first, does that give me 8?
No.
I'm putting in 1, I'm putting in 2, I'm putting in 3. If I do 1/2 to the second, what do I get just for 1/2 to the second? Not decimal. 1/4. What's 1/2 to the third, not decimal? 1/8. Ooh, how do I make 1/8 into 8?
Wait, why is it all equal to 8?
Oh, that's a good question. Never mind. Ignore that.
That candy written? I think so. I have.
Okay, so let's start again. Which one do I want to look at? Yeah, let's look at this one. How do I make 1/8 into 2? How do I make 1/4 into 4? That might be a little easier to look at. How do I make 1/2 to the first into 8? You have an idea?
I think, would you have to subtract 4?
From the exponent? So if we took away 4, you know what? I don't know, let's try it. If we took away 4, that's going to give me 1/2 to the -3. What does the negative exponent do? Reciprocates it, so we get 2 to the third, which is 8. All right, it works for one of them. Doesn't work for all of them. So if I do this one, -4, that's going to give me 1/2 to the -2. So I reciprocate it and square it. 2 squared, is that 4?
Yeah.
All right, it worked for 2 of them. Let's see if it works for 3 of them. Now let's see. We do 1/2, we do 3 minus 4, that's to the -1. Does that work? What's 1/2 to the -1 power? 2. So we have it. It's not the only way you could write that formula, but that's the way like the book would probably have it written. So we're going to do 1/2 to the n minus 4.
I did 2 to the 4 minus n.
Let me write down. Oh yeah, I think that works.
It does.
Okay. 2 to the 4 minus n. So if I put in 1,
So
yeah, that works. If I put in 4, that works. If I put in 5, yeah, that works too. Now, the reason why I didn't write it that way.
I mean, it doesn't follow your rule. of,
Right,
like,
that's why I didn't
1
write it
by
that way.
1/2, so I understand how
Uh-huh.
you got that.
Right, so this is fine. I would totally accept either. Okay? I just have to hand check the other one. All right, it's not exactly the next page, but it's like a little bit in there. This just has some terminology in there. I just want to show you. We were talking about sequence. This is the actual definitions. There's the definition per term. It talks about the input, the domain, the output, the range. And then it also talks about infinite sequences and finite sequences. You guys should know what infinite means. You should know.
And goes on forever.
Goes on forever. And when you look at the infinite sequence, you see it has these dot, dot, dots at the end, saying it's going on forever. So what's a finite?
It stops at a certain point.
It stops. Right. It doesn't go on forever, it just stops. But it's the same thing, it just, this one stops, that one doesn't. And then here it says you can write your rule with either a sub n equals, or you could also do f of n equals. I'm going to do a sub n equals every time because we haven't practiced a lot with a sub n. We've done tons of f of n. So you'll see me do a sub n more. We trust them. When you're ready for the next part, just let me know. Okay. Now, on the very last page, I actually want to start with this one. We are going to do numbers 3 and 4, but I want to do 5 first because my other class said they were zoned out by the time we did 5, and 5 was the most important one, so let's do that one first.
All right, let's do it.
Okay. Now 5 talks about writing it using summation notation. I have not showed you that yet. So all we're going to do for 5 right now is find a sub n. Okay, that's all we're going to do for right now. We'll do the summation notation next week.
You gotta leave it to constant.
Okay, so, well, you can come back. Where do you want to start? Where should we start?
Negative 1 plus 4.
Oh, ignore that. Let's just, there's something called, series when you add them all together, but let's look at just the terms. Okay, I just wanted this, let's just,
So
So
there's
negative
terms.
1,
Let's just-
4, negative 9, 6, 1,
So
negative
we
1.
have to add them.
not yet, that, we're not doing that today. We're just, well, in order to do like this formula thing, you would need to know the A sub n. In order to do this summation notation, you have to know the A sub n, but I'm not on Friday taking the time to explain summation notation yet. We're just gonna go over A sub n, okay? So let's just look at the sequence, not at what's called the series. Look at the sequence. All right, where should we start?
Actually, no, let's do it.
You can't rearrange it. Because, well, we can't rearrange it because it has to be, this is input 1, this is input 2, this is input 3, this is input 4, this is input 5. When we input these numbers, we get out the numbers that go with them. They have to be with those input numbers. Where could we start? How did you do your homework besides just matching this over the puzzle? Some of
Guess
you.
we check that.
Plug in and calculate it. I got.
Do you have your homework today? Okay. So, I thought you were gonna try to get that 8.
I was like a puzzle. I have an idea for this one.
What?
What would it would need to be like a negative number with key adding to the next one?
Okay.
Would it be
So,
minus the negative
yes,
then?
totally. What? Say that again, I didn't hear what you said. I
The
yesed,
negative then?
no, I yesed on Alex's idea, but not on yours, sorry. Okay,
Negative.
so the first thing that you wanna do is you wanna start looking at the numbers that are in black, and you notice that we have a negative every other one. You can start trying to do your, like, is there something we add each time?
No.
Well, that's actually minus. This would be minus 5, this would be plus 30, no, I totally did them backwards. This would be plus 5 minus 13, this would be plus 25 minus 41. All right, well, that doesn't work. Maybe I'll try a second time. This is gonna be minus 18, this is gonna be plus 38, minus 66 or something. The numbers are just gonna keep getting bigger, they're getting further apart, but what you notice is every single time they're alternating positive, negative. So when this happens, when we are alternating positive, negative, what you wanna do is you wanna put a -1 as part of your summation notation to the end. Now we have to figure out if -1 to the n is getting us the correct signs. Because the first one has to be negative, the second one has to be positive, not vice versa. So if I put in -1 to the first, what do I get out? Okay, -1. If I put in -1 to the second, so I'm putting my input numbers in. Let me make those red so you can see. These are the input numbers. If I put in -1 to the second, what do I get out?
1.
Positive 1. If I put in -1 to the third, what do I get out? Is that following the pattern? Do I have a negative first, then a positive second, then a negative third? Okay, so that part is part of our answer. -1 to the n is part of our answer. Now we've taken care of the negative positive thing. Yes?
No.
No, because if I put in 5, do -5 to the fifth.
They're all
I don't know what
squares.
number that is. Let's big number.
It's short. That's very good.
It is possible that you can do negative some number if it works. There are more than one answer sometimes, so sure. I'm just trying to give you pieces. So now what I'm going to do is I'm going to look at these numbers, but only look at the positive versions because I've already taken care of the sign switches. let's just look at a positive version. So this is plus 3, this is plus 7, this is plus 9, this is, right? Or having the wrong word. This is plus 5, plus, I know what they're supposed to be. 5, 7, and 9. And then from there, plus 2, plus 2, plus 2. So what's that mean if we have two finite differences?
Squared.
We know it's going to be squared. So we're going to try just n squared. We're going to try just n squared. We might have to switch it around. If I put in 1, no, we're ignoring that because I already got the negative part. If I put in 1, do I get 1? If I put in 2, do I get 4? If I put in 3, do I get 9? Does that work every single time?
Yes.
Okay, so I have the other part of it. The other part of it is n squared. So you kind of have to look at the negatives separate from the number itself. Nope, because you have to have -1 to an exponent also, so that we can switch it between negative or positive. If every single one of them was negative, then I'd have a -1 in front.
Oh, I get that.
But since they're
Okay.
switching, we need that -1 to also change. Okay? If I had just negative numbers the whole time, I wouldn't need to the n power. I would just have -1 in front.
So then for every one that's like that.
When you have the alternate,
Negative
-1 to the n, yeah. But it could be -1 to the n plus 1. Like, it could say n plus 1 here. Because
Yeah.
if it started with a positive, you would need that to be squared instead of to the first power. So you just kind of have to like play around with it. But that is the answer for that one. The other two are just a review of what we did yesterday. Let's quickly go through those, just really quickly. Looking at number 3, looking for a pattern. What's happening in number 3? We're adding the same thing each time. Number 3, we're adding the same thing. What are we adding? So when we add the same thing each time, it's linear, and every time it's linear, we're going to take that number we're adding and put it next to n. And then we're going to check to see if it works as is or if we have to change it. So I have to think about my input number. If I input 1, do I get out -3? If I input 2, do I get out -1? I'm going to have to do something to it because I don't get it the way it is. Look at the third one. If I put in 3, I get 6. How do I make that into 1? -5. So does that work for every single one?
Maybe.
I'll put it in and check.
Yes.
So then our pattern to n minus 5. Last example for today is one of those fraction kinds. We did a fraction kind last time. So just to review the fraction kind. I'm looking at this one. Is there something that we notice?
Everything's over 5.
Okay, it's always over 5. So look at the top completely separate from the bottom. This one's always over 5. A sub n is going to be something over 5. So I'm only going to look at my top numbers with my input 1, 2, 3, 4. I'm only going to look at the top numbers. So if I look at the top numbers, 2, 4, 6, 8.
That's 2. Who do we?
Is that linear? From 2 to 4, we plus 2. From 4 to 6, we plus 2. From 6 to 8, we plus 2. So this is going to be 2n. But is it 2n or do I need to add or subtract something? Plus. Let's try it. 2 times 1, does that give me 2? 2 times 2, does that give me 4?
Yes.
2 times 3, does that give me 6?
Yes.
So the answer is yes, 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 then this is right. I don't need to do anything else to it. It's just 2. Okay, so your worksheet Well, if you didn't finish the other one, you need to finish the other one, but your worksheet is, just the same stuff, finding the nth term. Huh? You wanna do one while you're in class, just for,
I'm gonna see if I can actually
or you're gonna do
just show work for the.
Uh-huh.
I totally didn't just do it with the puzzles.
I didn't hear what you said for one.
You have 8 pages and 0 time.
Huh?
You don't have time to study for exams.
What are you talking about? You have time right now, and we have an entire new lesson that we're learning on Monday and Tuesday.
Really?